Step outside on a bright sunny day and what do you see? Perhaps a spider web glistening with morning dew, its intricate design a testament to nature's artistry. Maybe you spot a hummingbird, its iridescent feathers catching the light as it hovers effortlessly, sipping nectar from a flower. Look closely at the veins on a leaf, branching out like tiny rivers, transporting life-giving nutrients. These wonders, often overlooked in our busy lives, are marvels of design and engineering. For millennia, humans have looked to the natural world for inspiration. We've found solace in its beauty, sustenance in its bounty, and guidance in its wisdom. Yet it's only recently that we've begun to truly appreciate the genius of nature's designs and their potential to solve some of humanity's most pressing challenges. Imagine a world without Velcro, the ingenious fastener that secures everything from shoes to spacecraft. This seemingly simple invention, with its two strips of fabric that magically cling together, was inspired by nature's own design. In 1941, Swiss engineer Georges de Mestral was intrigued by the burrs that clung stubbornly to his dog's fur after a walk in the woods. Upon closer examination under a microscope, de Mestral discovered the secret behind the burr's tenacity, tiny hooks that latched onto the loops of fur. This simple yet effective mechanism sparked an idea. Could a similar design be replicated to create a reusable fastener? Thus Velcro was born, a testament to the power of observing and learning from nature's ingenious solutions. Biomimicry, at its core, is a profound shift in perspective. It's a move away from viewing nature solely as a resource to be extracted and towards recognizing it as a mentor to be emulated. It's about asking the question, how has nature already solved this problem? This approach requires a multidisciplinary lens, bringing together biologists, engineers, architects, designers, and other experts to collaborate and find solutions inspired by the natural world. It's about understanding the underlying principles that govern nature's designs and translating them into practical applications. The promise of biomimicry extends far beyond simply mimicking nature's forms. It is an approach that seeks to understand the deep-rooted principles and strategies that nature has developed over billions of years. By studying these natural processes, we can uncover solutions that are not only innovative, but also sustainable and efficient. It's about delving into the underlying principles that govern these designs and adapting them to solve human challenges in innovative and sustainable ways. Scientists and engineers are increasingly turning to nature for inspiration, looking at how plants, animals, and ecosystems solve complex problems. This approach can lead to breakthroughs in various fields, from architecture to medicine. It's about recognizing that nature, through billions of years of evolution, has already solved many of the problems we face today. For instance, the way trees manage water and nutrients can inspire more efficient agricultural practices, and the structure of a bird's wing can lead to more aerodynamic and fuel-efficient aircraft designs. Imagine a world where buildings purify the air as efficiently as a rainforest, where the very structures we live and work in contribute to the health of our environment. These buildings could harness natural light, regulate temperature, and even generate their own energy, reducing our reliance on non-renewable resources, where cities function as seamlessly as an ecosystem with green spaces and biodiversity integrated into urban planning. These cities would not only be more pleasant to live in, but also more resilient to environmental challenges such as climate change and natural disasters, and where transportation systems are as energy efficient as a soaring bird. By mimicking the streamlined shapes and efficient movements found in nature, we can develop transportation methods that use less energy and produce fewer emissions. This is the potential that biomimicry unlocks. It offers a vision of the future where human innovation and natural wisdom come together to create a harmonious and sustainable world. It offers a path towards a future where technology exists in harmony with nature, rather than at its expense. Renewable energy sources like solar panels and wind turbines, inspired by natural processes, can help us reduce our carbon footprint and combat climate change. The journey of biomimicry is just beginning, As we continue to explore and understand the natural world, we will discover even more ways to apply its principles to our own lives. As we delve deeper into the wonders of the natural world, we uncover a wealth of untapped potential. Each discovery brings us closer to a future where our built environment and natural ecosystems coexist in perfect balance. By embracing nature's wisdom and emulating its time-tested designs, we can create a more sustainable, resilient, and awe-inspiring future for generations to come. The promise of biomimicry is not just a dream. It is a tangible path forward, guiding us towards a world where human ingenuity and the natural world thrive together. By embracing nature's wisdom and emulating its time-tested designs, we can create a more sustainable, resilient, and awe-inspiring future for generations to come. We can create a more sustainable, resilient, and awe-inspiring future for generations to come. Deep within the African savanna, seemingly barren landscapes give way to towering structures, testaments to the architectural prowess of tiny creatures, termites. These intricate mounds, often reaching heights of several meters, are not merely piles of dirt, but carefully designed ecosystems that regulate temperature, humidity, and ventilation with astonishing precision. These remarkable feats of engineering have captivated scientists and architects alike, offering valuable insights into sustainable building practices. How do termites, with their limited resources and diminutive size, manage to construct such impressive and functional homes? The answer lies in their intricate understanding of passive ventilation and thermal regulation. The mounds are designed with a network of tunnels and chambers that act as natural chimneys, drawing cool air in from the ground and expelling hot, stale air through the top. This constant circulation of air maintains a stable internal temperature, even as the outside temperature fluctuates dramatically between day and night. In the heart of Harare, Zimbabwe, stands a testament to the transformative power of biomimicry, the Eastgate Center. This award-winning office and shopping complex is a beacon of sustainable design inspired by the remarkable ventilation system of termite mounds. Designed by architect Mick Pierce, in collaboration with engineers at Arup, the Eastgate Center stands as a shining example of how nature's wisdom can be harnessed to create comfortable and energy-efficient buildings, even in challenging climates. The Eastgate Center's unique architecture mimics the porous structure and chimney-like ventilation system of termite mounds. The building's concrete exterior is riddled with strategically placed holes and vents that facilitate natural airflow. During the day, cool air is drawn in from the ground level, circulating through the building and pushing warm air upwards. This warm air is then vented out through chimneys located at the top of the building, creating a continuous flow of fresh air. The lotus flower, revered for its beauty and symbolism of purity, holds a fascinating secret in its petals' exceptional water repellency. Even amidst muddy waters, the lotus emerges pristine, its leaves seemingly impervious to dirt and grime. This remarkable self-cleaning ability, known as the lotus effect, has captivated scientists and engineers alike, inspiring innovations in materials science and surface engineering. The secret behind the lotus effect lies in the unique microscopic structure of its leaves. The leaf surface is covered with tiny bumps, or papillae, coated with a waxy substance. This dual structure creates a superhydrophobic surface, meaning water droplets bead up and roll off with ease, carrying away dirt and other contaminants in the process. This self-cleaning mechanism not only keeps the lotus looking immaculate, but also prevents the growth of bacteria and fungi, ensuring the plant's health and longevity. Antoni Gaudí, the visionary architect behind Barcelona's iconic Sagrada Familia, looked beyond conventional architectural forms, finding inspiration in the natural world. His masterpiece, still under construction over a century after his death, stands as a testament to the power of biomimicry, showcasing how nature's forms and principles can inspire awe-inspiring and structurally sound designs. Gaudí believed that nature was the ultimate teacher, and he sought to emulate its organic forms and structural efficiency in his work. He drew inspiration from trees, bones, shells, and other natural structures, incorporating their shapes and patterns into his designs. The Sagrada Familia's soaring columns, for instance, resemble trees reaching for the heavens, branching out to support the weight of the vaulted ceilings. In nature, an organism's skin is more than just a covering. It's a dynamic interface that regulates temperature, protects from the elements, and even facilitates communication. Architects are now looking to nature for inspiration in designing building skins that adapt to changing environmental conditions, enhancing energy efficiency and occupant comfort. The pine cone, a seemingly simple structure, offers a fascinating example of bio-inspired adaptive design. Its scales open and close in response to changes in humidity, protecting the seeds within from harsh weather conditions. Inspired by this mechanism, researchers have developed building facades with responsive elements that adjust to regulate temperature and light. As we stand at the cusp of a new era in architecture, biomimicry offers a path towards a more sustainable and harmonious built environment. By embracing nature's wisdom and emulating its time-tested designs, architects can create buildings that are not only functional and efficient, but also inspiring, resilient, and integrated with the natural world. Imagine cities where buildings mimic the forms and functions of trees, purifying the air, providing shade, and even harvesting solar energy. Picture skyscrapers that mimic the intricate ventilation systems of termite mounds, regulating temperature and airflow with minimal energy input. Envision homes with self-healing walls, inspired by living organisms, adapting to changing weather conditions and reducing maintenance needs. The sleek, streamlined form of a kingfisher diving into water, barely a splash disturbing the surface, is a marvel of natural engineering. This bird, with its vibrant plumage and precise movements, has long fascinated both birdwatchers and scientists alike. It seems a world away from the thundering speed of a bullet train, a marvel of human engineering designed to transport people at incredible speeds across vast distances. Yet, this very bird, a master of both air and water navigation, inspired a revolutionary design in high-speed rail technology. The kingfisher's ability to dive into water with such grace and efficiency caught the attention of engineers looking to solve a pressing problem. The challenge? Reducing the ear-splitting sonic boom that plagued early bullet trains as they exited tunnels. This problem was not only disruptive to communities near the tracks, but also wasteful of energy, creating a significant barrier to the efficiency and expansion of high-speed rail networks. Eiji Nakatsu, an engineer with Japan's Shinkansen bullet train project, found his inspiration in the kingfisher's beak. Nakatsu, who was also an avid birdwatcher, noticed the unique shape and function of the kingfisher's beak and saw a potential solution. This bird's elongated aerodynamic beak allows it to transition seamlessly from air to water with minimal resistance, a feat particularly impressive given the difference in density between the two mediums. The beak's shape reduces the impact and splash, allowing for a smooth entry. This natural design, honed by millions of years of evolution, provided a blueprint for engineers. The kingfisher's beak became a model for reducing resistance and noise, crucial for improving the performance of high-speed trains. Nakatsu realized that a similar design principle could be applied to the nose of the bullet train. By mimicking the kingfisher's beak, the train could transition more smoothly from the low-pressure environment inside a tunnel to the higher-pressure atmosphere outside. This innovation not only reduced the sonic boom, but also improved energy efficiency, making the trains quieter and more sustainable. The kingfisher's influence on high-speed rail is a testament to the power of biomimicry, where nature's solutions inspire human innovation. Sometimes the most impactful innovations are inspired by the simplest of observations. Such is the story of Velcro, a ubiquitous fastener found on everything from children's shoes to aerospace equipment. This seemingly simple invention, with its two strips of fabric that magically cling together, owes its existence to the humble burdock plant and the keen eye of Swiss engineer Georges de Mestral. In 1941, while returning from a walk in the Swiss Alps, de Mestral noticed burdock burrs tenaciously clinging to his dog's fur. Intrigued by their stubborn attachment, he examined the burrs under a microscope, revealing their secret tiny hooks that effortlessly latched onto the loops of fur. This simple yet effective mechanism sparked an idea. Could a similar design be replicated to create a reusable fastener? The gecko, a master of vertical surfaces, seems to defy gravity as it effortlessly scales walls. This small creature has fascinated humans for centuries, not just for its agility but for the mystery behind its incredible adhesive abilities. And even hangs upside down, this remarkable ability has captivated scientists for centuries, leading to the discovery of a fascinating adhesion mechanism. The gecko's feet are a marvel of natural engineering, allowing it to cling to surfaces that would be impossible for most other creatures. That has inspired a new generation of biomimetic materials. Unlike suction cups or sticky adhesives, gecko feet rely on a unique interplay of microscopic hairs and intermolecular forces, allowing them to cling to surfaces with astonishing strength and detach with ease. This has led to innovations in various fields, from robotics to medical devices, where similar adhesive properties are highly desirable. Each gecko foot is covered in millions of microscopic hairs called setae. These setae are the secret behind the gecko's adhesive prowess, providing a large surface area for interaction with different surfaces. And each seta branches out into hundreds of even tinier hair-like structures called spatulae. These spatulae are so fine that they can interact with the very molecules of the surface, creating a bond that is both strong and reversible. These spatulae, so small they're only a few hundred nanometers wide, interact with surfaces at the molecular level, forming weak bonds called van der Waals forces. These forces are individually weak, but when multiplied by the millions of spatulae on a gecko's foot, they create a powerful adhesive effect. While individually weak, the sheer number of spatulae on a gecko's foot creates a cumulative adhesive force strong enough to support its weight, even on smooth surfaces like glass. This incredible natural adaptation not only allows the gecko to navigate its environment with ease, but also provides a blueprint for developing new technologies that mimic this extraordinary adhesive capability. In the harsh, arid landscape of the Namib Desert, survival hinges on the ability to secure a most precious resource. Water. The Namib Desert beetle, a master of adaptation, has evolved a unique strategy for collecting water from thin air, a feat that has captivated scientists and inspired innovative solutions for water harvesting in arid regions. Every morning, the Namib Desert beetle climbs to the crest of sand dunes and orients its body towards the incoming fog, which rolls in from the Atlantic Ocean. Its hardened outer wings, covered in a pattern of hydrophilic bumps and hydrophobic troughs, act as a natural condenser. Tiny water droplets from the fog condense on the bumps, accumulating into larger droplets that roll down the troughs and into the beetle's mouth. The sleek, streamlined form of a shark gliding effortlessly through water is a testament to millions of years of evolution optimizing for speed and efficiency. But the shark's remarkable hydrodynamics are not solely due to its shape. Its skin, too, plays a crucial role in reducing drag and enhancing its underwater agility. This realization has led to a wave of biomimetic innovations, from swimsuits designed to reduce drag to coatings for ships and aircraft that improve fuel efficiency. Unlike the smooth scales of most fish, a shark's skin is covered in tiny tooth-like structures called dermal denticles. These denticles are not merely armor but create a complex, textured surface that disrupts the flow of water, reducing drag and turbulence. This allows the shark to swim faster and with less effort, conserving precious energy. As we face increasingly complex challenges in the 21st century, from climate change and resource scarcity to healthcare and technological advancement, the field of biomimicry offers a compelling path forward. by embracing nature's time-tested designs and principles, we can unlock a new era of sustainable and innovative solutions across industries. Imagine a future where buildings generate their own energy like trees, where transportation systems mimic the efficiency of bird flight, and where medical treatments harness the regenerative power of living organisms. This is the promise of biomimicry, a field limited only by our imagination and our willingness to learn from the natural world. For millennia, humans have looked to nature for healing remedies. From traditional herbal medicines to the soothing properties of honey, the natural world has long provided a source of solace and relief from ailments. Today, the burgeoning field of biomimicry is taking this ancient wisdom to a whole new level, drawing inspiration from nature's intricate designs and processes to revolutionize medical treatments and improve human health. Biomimicry in medicine goes beyond simply extracting medicinal compounds from plants and animals. It involves delving into the ingenious mechanisms that allow living organisms to thrive in diverse environments, from the antibacterial properties of shark skin to the regenerative capabilities of starfish. By understanding and emulating these natural processes, scientists and engineers are developing innovative medical technologies that are more effective, less invasive, and more harmonious with the human body. The ocean, teeming with life, is also a breeding ground for bacteria. Yet sharks, despite their constant exposure to these microscopic hitchhikers, remain remarkably resistant to bacterial infections. This intriguing observation led scientists to investigate the unique properties of shark skin, uncovering a fascinating mechanism that has inspired a new generation of antibacterial surfaces. Unlike the smooth scales of most fish, a shark's skin is covered in tiny, tooth-like structures called dermal denticles. These denticles, long recognized for their hydrodynamic properties, also create a surface texture that inhibits bacterial attachment and growth. The pattern and spacing of the denticles disrupt the formation of biofilms, the slimy layers that bacteria use to adhere to surfaces and protect themselves from antibiotics and the immune system. The thought of needles sends shivers down the spines of many, and for good reason. The sharp, pointy instruments, while essential for delivering life-saving medications and drawing blood, can also cause pain and discomfort. But what if we could make needles less intimidating, even painless? Biomimicry, drawing inspiration from nature's ingenious designs, offers a promising solution. Consider the porcupine, covered in thousands of quills that deter predators with their painful prickliness. While seemingly intimidating, the porcupine's quills hold a surprising secret. Their barbed structure allows for easy penetration but makes removal difficult. A clever evolutionary adaptation for defense. However, this same principle applied in reverse has inspired the development of less painful needles. The humpback whale, a gentle giant of the ocean, navigates its underwater realm with remarkable agility and grace, thanks in part to its massive flippers. These flippers, despite their size, are surprisingly maneuverable, allowing the whale to execute tight turns and powerful strokes. This impressive feat of biomechanics has captivated scientists and engineers, leading to bio-inspired designs for more agile and efficient prosthetic limbs. The secret to the humpback whale's flipper agility lies in the unique arrangement of bumps, called tubercles, along the leading edge of its flippers. These tubercles, far from being hydrodynamic hindrances, actually reduce drag and enhance lift, allowing the whale to make sharper turns and generate more power with each stroke. This discovery challenged conventional aerodynamic thinking, which favored smooth surfaces for reducing drag. The human body possesses a remarkable ability to heal itself. From minor cuts and scrapes to more serious injuries, our bodies initiate a complex cascade of events to repair damaged tissues and restore function. Yet some wounds prove more challenging to heal, leading to chronic pain, impaired mobility, and even life-threatening infections. Biomimicry, turning to nature's master healers for inspiration, offers promising avenues for enhancing wound healing and tissue regeneration. Consider the starfish, a creature renowned for its remarkable regenerative capabilities. If a starfish loses an arm, it can regenerate a new one, complete with all its intricate structures. This remarkable feat is made possible by specialized cells that can differentiate into various tissue types, allowing the starfish to essentially rebuild lost body parts. As we venture deeper into the 21st century, the field of medicine faces unprecedented challenges, from aging populations and rising healthcare costs to the emergence of drug-resistant superbugs and the increasing prevalence of chronic diseases. Biomimicry, with its focus on learning from nature's time-tested solutions, offers a beacon of hope and a path towards a healthier future. Imagine a future where medical treatments are less invasive and more targeted, where drugs are designed to mimic the body's own healing mechanisms, and where hospitals are designed to promote healing and well-being, drawing inspiration from the restorative power of nature. This is the promise of a bio-inspired approach to health. As we've journeyed through the fascinating world of biomimicry, from the soaring heights of nature-inspired architecture to the intricate details of bio-inspired medical devices, one overarching theme emerges: the boundless capacity of nature to inspire innovation. We've seen how the humble burdock plant inspired the invention of Velcro, how the kingfisher's beak guided the design of high-speed trains, and how the shark's skin holds the key to combating bacterial infections. These examples, diverse and awe-inspiring in their own right, represent mere threads in a vast tapestry of nature-inspired innovation. Each success story, from self-healing materials mimicking the resilience of living organisms to water harvesting technologies inspired by desert beetles, underscores the profound potential of biomimicry to address some of humanity's most pressing challenges. For too long, we've viewed technology as separate from and often at odds with nature. We've built cities that consume vast amounts of energy, transportation systems that pollute our air and water, and industries that deplete our planet's finite resources. Biomimicry offers a radical departure from this unsustainable paradigm, presenting a vision of a future where technology exists in harmony with the natural world, not at its expense. Imagine a world where buildings, like trees, purify the air, provide shade, and even generate their own energy. Picture cities designed as interconnected ecosystems where waste is minimized, resources are used efficiently, and transportation systems mimic the elegance and efficiency of bird flight. Envision a future where medical treatments inspired by nature's healing powers work in concert with the body's own regenerative capabilities, minimizing side effects and promoting long-term well-being. Biomimicry, at its core, is not simply about copying nature's forms, but about understanding the deep principles that govern those forms. It's about asking not just what can we mimic, but how does nature solve this problem? And what can we learn from nature's 3.8 billion years of research and development? Nature operates on principles of efficiency, using only the energy and resources it needs. It embraces resilience, adapting to changing conditions and bouncing back from adversity. It prioritizes closed-loop systems, where waste from one process becomes food for another. These principles, embedded in the very fabric of life, hold the key to creating a more sustainable and thriving future for humanity. The challenges facing our planet: climate change, resource depletion, biodiversity loss, and pollution can seem overwhelming, even insurmountable. Yet amidst these daunting realities, biomimicry offers a beacon of hope, a powerful reminder that the solutions to many of our problems may already exist within the intricate designs and processes of the natural world. The time for incremental change has passed. We need a revolution, a fundamental shift in how we design, build, and live on this planet. Biomimicry, with its focus on learning from nature's wisdom and emulating its time-tested solutions, provides the framework for this revolution. For too long, we've viewed nature as something separate from ourselves, a resource to be exploited or a backdrop for our endeavors. Biomimicry invites us to shift this perspective, to see nature not as something to be conquered, but as a wise and generous mentor, offering guidance and inspiration for creating a more sustainable and fulfilling future. Nature has spent billions of years perfecting its designs, refining its processes, and adapting to ever-changing conditions. It has developed solutions for capturing energy, managing resources, purifying air and water, creating strong yet lightweight materials and healing wounds. Solutions that are inherently sustainable and often far more elegant and efficient than anything humans have engineered. Imagine a world where cities function like forests, purifying the air, providing shade, and even harvesting energy from the sun. Picture buildings that mimic the intricate ventilation systems of termite mounds, regulating temperature and airflow with minimal energy input. Envision transportation systems that glide through the air or water with the efficiency of birds and fish, minimizing noise and pollution. Imagine a world where medical treatments, inspired by nature's healing powers, harness the body's own regenerative capabilities, promoting faster healing and minimizing side effects. Picture a future where materials are designed to decompose harmlessly back into the environment, eliminating waste and pollution. Envision a world where energy is abundant and clean, harnessed from renewable sources, inspired by the photosynthetic prowess of plants.